Okay, calculus students, let's take a look at this extreme value theorem example. I've always liked the extreme value theorem. It's kind of concrete, exactly what you need to do. I'll tell you before we get started. To find the extreme values, I'm talking about the global maxima and minima. What you need to do is test all critical points and the endpoints of the interval. That's the name of the game. Let's get right to it. You guys have been down this road. And we want to look at the new kid on the block. All right, here's the problem. All right, this is going to be a little scary for you. Let f of x equal e to the negative x times sine x. Here's what we need to do. Just a few things. First of all, we're working on the closed interval between 0 and 2 pi. A, we have to find f prime. Oh, I can find a derivative, that's not so bad. B, we got to find f double prime. Okay, I think I can do that. C, we got to find the critical points. The critical points? Yeah, the critical points of f, where f prime is 0 or does not exist. Oh, okay. I think I'm okay. D, we got to find any inflection points. Oh gosh, we're getting a little carried away here. We got to find the inflection points. How do I find the inflection points? Well, possible inflection points exist where f double prime, we're going to have to find where f double is equal to 0. Possible inflection points, not guaranteed inflection points. Be careful. And lastly, we got to use the candidates test to identify the global max and the global min of f. Oh, and one more thing. There's no calculator allowed here. And I can't use, right, you can't use the calculator. I tell you what, Foster, I just am really having problems with you. Why, you no good. Can't believe you're going to do this stuff. It's just so, it makes me frustrated. Oh, you guys will be fine. You'll see this isn't so bad. So first of all, we got to find f prime. All right, so just giving you the problem again, we'll do these on multiple screens. To find f prime, I realize I got to use the product rule. Okay, and so the product rule says go u prime v plus uv prime. Let's do it. If you're going to find f prime, you have to first take the derivative of u. This requires the chain rule. The derivative of e to something complicated is e to something complicated times the derivative of the inside function, which is negative 1. When you take the derivative of u, you get negative e to the negative x times leave v alone, plus leave u alone, and take the derivative of v. The derivative of sine is cosine x. Okay, now I'm just going to format this so it's a little cleaner to use, because we do have to find the second derivative here. My first step is I'm going to factor out that e to the negative x. I realize there's a negative in front of that first one, okay? This is going to be negative sine x plus cosine x left over in the parentheses. And now I'm just going to switch the order within the parentheses there and get e to the negative x times cosine x minus sine x. I got the first derivative. Letter B challenges me to find the second derivative. Well, I'm going to use the first derivative. It says e to the negative x times the quantity, cosine x minus sine x. This is going to require another product rule. So this time u is e to the negative x, and v is cosine x minus sine x. And again, the blueprint for the product rule u prime v plus uv prime. I'm taking the derivative of u, we've been down this road, negative e to the negative x, times leave v alone, cosine x minus sine x, plus leave u alone, e to the negative x, and then take the derivative of what's in parentheses there. That's going to be, let's see, the derivative of cosine x is negative sine x minus the derivative of sine x is cosine x. Again, a little work reformatting this. What I'm going to do is factor out an e to the negative x. Now I realize that first e to the negative x has a negative sign in front of it. That's why I've got the negative in front of the cosine x now, all right? So now I've factored out e to the negative x. The first quantity now becomes negative cosine x plus sine x minus sine x minus cosine x. Well, that makes things a little cleaner on the inside. Just emphasizing that negative sign. I didn't forget about that, okay? That exists and has changed the sign of the first two terms of the first quantity there. So I get negative 2 cosine x as a simplified version of what's in parentheses. Do you see the plus sine x and the minus sine x there? The plus sine x and the minus sine x cancel. So I lost $1, I lost another $1, I'm down $2, I'm down 2 cosine x. I've got the second derivative. And you'll most often see it written like this, negative 2e to the negative x cosine x. Next, we're asked to find critical points. I have to know what critical points are. This is where f prime is 0 or f prime does not exist. So we go back to our f prime function. F prime equals e to the negative x times cosine x minus sine x. Now this is a little tricky. You need to know that we're going to set this equal to 0. Because f prime, if we can find where f prime is equal to 0, we have found a critical point. And that first e to the negative x right here in the cloud, you can look at this on the calculator, but think about this with me for just a moment. I could rewrite this as 1 over e to the x. No matter what you put in for x, you guys, a positive or a negative number, e to the negative x will always be positive. More importantly, e to the negative x will never be 0. You see, I basically have two things being multiplied together here. One of them's got to be 0 in order for the product to be 0. And e to the negative x will never be 0. So I'm just going to remove it from the equation because it's always going to be positive. And so now my equation is a simple 0 equals cosine x minus sine x. How do you solve that, Foster? I'm going to add sine x to both sides of the equal sign. And I really have to know, where is it that, what radian measure is it, where the sine of x is equal to the cosine of x? If you're thinking unit circle, you and I are on the same page. So I got to use the unit circle on the interval, the closed interval from 0 to 2 pi to figure out when sine and cosine have exactly the same output. Well, check it out. At that location, the ordered pair on the unit circle is root 2 over 2 comma root 2 over 2. Now remember, that's cosine and sine, right, on the unit circle. That occurs at pi over 4. So I know at pi over 4, I have a critical point. And 180 degrees away from that, I have a second ordered pair, which reads negative root 2 over 2 comma negative root 2 over 2. This is the second location on the unit circle where both the cosine and the sine are equal to one another. This means that the location is 5 pi over 4. We can do this. It won't be so bad. Let's get it going. So this is the original problem again. F of x equals e to the negative x sine x on the closed interval from 0 to 2 pi. So we got to take f prime. That's why I'm putting that u and v there. I realize that I've got to use the product rule because I have e to the negative x times sine x. Product rule. Blueprint is u prime v plus uv prime. I take the derivative of u. Well, e raised to the something complicated has derivative e to that something complicated times the derivative of that something complicated, which is negative 1. So we have f prime of x equals the derivative of u is negative 1 times e to the negative x times leave v alone, sine x, plus leave u alone, e to the negative sine x, and take the derivative of v, cosine x. Okay, so my next two steps, you guys, I'm just going to rearrange this action a little bit. The first thing I'm going to do is factor out e to the negative x. Left over, I know there's that negative sign in front of the first term, so I have negative sine x plus cosine x. And I'm just going to switch the order inside the parentheses here and write this as cosine x minus sine x. I got the first derivative. My next challenge is the second derivative. Well, again, this is the derivative of the first derivative. And the first derivative is e to the negative x times something. So I got to use the product rule again. Again, I label u and v. I write the blueprint u prime v plus uv prime. The derivative of u, again using the chain rule, is negative e to the negative x times leave v alone, plus leave u alone, e to the negative x, and take the derivative of that stuff in parentheses. That's going to yield negative sine x minus cosine x. And I'm going to take a moment to rewrite this in a little cleaner format. The first thing I'm going to do is factor out an e to the negative x. I realize that first term has a negative e to the negative x, and I carry that through. Negative cosine x plus sine x, that's plus sine x. I had to change the operation sign in front of that, minus sine x. And continuing here, minus sine x minus cosine x. Now things inside that big quantity simplify for me a little bit here. And I'm just pointing out, I'm not ignoring that negative e to the negative x. I hope you guys can see how we factored out e to the negative x successfully here. So now the simpler version here is e to the negative x times negative 2 cosine x. Where'd that come from? Well, I know that you see it in parentheses, that plus sine x and that minus sine x. Those cats cancel. And then my mind is thinking, oh, I lost $1, then I lost another $1. I'm down $2. I'm down 2 cosine x. And finally, f double is equal to negative 2 e to the x cosine x, just writing it in the order with the coefficient first, and e to the negative x second, and the trigonometric cosine x last. Success! We've got f double. Let's keep cranking. Our next challenge is to find critical points. Critical points are where the derivative is 0 or fails to exist. So I'm going to write down f prime. We already found that. I know what f prime equals. It equals e to the negative x times cosine x minus sine x. And I've got to set that equal to 0. Now, it's important that you're practicing these type of problems, or this will never occur to you. I basically have two quantities being multiplied together. E to the negative x times all that stuff in parentheses. Well, if you graphed e to the negative x, you would see this for yourself, but I'm here to tell you that e to the negative x will never be 0. It is always positive. So I'm making a special note of this. This is always going to be positive. Well, if you're multiplying two things together, one of them's got to be 0 in order for the product to be 0. So I can rid myself of e to the negative x and just focus on the cosine x minus sine x, setting that equal to 0. I'm going to add sine x to both sides of the equal sign. And truth be known here, I'm thinking, when is sine x equal to cosine x? For what radian measure? I'm thinking the unit circle, just like you. So where on the, I got to use the unit circle and figure out what ordered pairs do we have such that the x and the y are exactly the same sign and everything. Well, here's my unit circle. I know that at this location I have that scenario, root 2 over 2 comma root 2 over 2. That exists, remember that's cosine, that represents cosine and then sine. That exists at pi over 4. So I know I've got a critical point at pi over 4. Again, at pi over 4, I have root 2 over 2, comma root 2 over 2. I'm looking for those special locations on the unit circle where the x and the y coordinates, or the cosine and the sine, are identical. This also exists on the third quadrant, where the ordered pair is negative root 2 over 2, comma negative root 2 over 2. The radian measure there is 5 pi over 4. So I've got a second critical point at 5 pi over 4. I found the critical points. What about where f prime does not exist? Yeah, between 0 and 2 pi, you will not be able to find a radian measure that you can plug into that function such that the function does not exist. Most often, you know, when you have a fraction or something, you're looking for locations where the denominator is 0. That's a location where the function would not exist. Okay, so now part D is I want to find inflection points. Well, I can locate possible inflection points wherever the second derivative is equal to 0. I know the second derivative. I've already found that. The second derivative is equal to negative 2 e to the negative x times cosine x. And again, I want to set that cat equal to 0. And for the same logic as earlier, this first part will never be equal to 0. Go ahead and graph it if you want. You can test it for yourself. There's not an x value I can put in there to make that part 0. So I'm really just focused on the cosine x. Where's the cosine x equal to 0? Again, I'm leaning on my unit circle. At that location, the cosine is equal to 0. That location is pi over 2. That's a possible inflection point at pi over 2. How do you know if it's a true inflection point or not? It's a true inflection point if the second derivative equals 0 and the sign of the second derivative changes at that magic point. So I'm just looking at the unit circle to convince myself of this. At 3 pi over 4, in the second quadrant, I have negative root 2 over 2, and in the first quadrant, I have positive root 2 over 2. This has satisfied me that the sign is indeed changing here. And so I've got an inflection point at pi over 2. For the exact same logic, you guys, 3 pi over 2, where you have the order pair 0, comma, negative 1, the cosine is negative in the third quadrant, positive in the fourth quadrant, so I know it changed sign there. So I have a second inflection point at x equals 3 pi over 2. Again, same exact logic there. So I've done A, B, C, and D. And I've done the hard part. I've done the crucial steps in order to find the global max and min. And we do what's called the candidates test to determine the global max and min. What are the candidates? Always the same, you guys. Test the endpoints of the interval and the critical points, which we've already identified. So the endpoints of the interval are at x equal, the interval goes from 0 to 2 pi, right? That's why I'm testing, long-winded. There's our function, f of x equals e to the negative x sine x. X equals 0 is the first endpoint. X equals 2 pi is the right endpoint of the interval. And we have two critical points, x equals pi over 4 and x equals 5 pi over 4. So how do we test these? Well, wherever we see an x, first thing we're going to do is test x equals 0. Wherever we see an x, we're going to plug in 0. That makes e to the negative 0 times sine 0. Anything raised to the 0 power is equal to 1. The sine 0, unit circle, is equal to 0. I get 0. As we spoke earlier, this time, whenever I see an x, I'm putting in 2 pi. This will not surprise you that the sine of 2 pi is also equal to 0. I also get 1 over e to the 2 pi. I'm not sure what that is, but times 0, I don't care what it is. Whatever times 0 is 0, I'm going to get a 0 for when I test 2 pi. All right, let's test pi over 4. I get e to the negative pi over 4 times the sine of pi over 4. Well, I'm going to write this so my brain understands it a little better. 1 over e to the pi over 4, so I no longer am worried about that negative exponent. And the sine of pi over 4 we found earlier was root 2 over 2. Now, you guys, I'm not sure what that number is, but I do know that this is a positive number. I'm talking about root 2 over 2e to the pi over 4 is a positive number. Now, the calculus, Foster Wheeler AP exam, they're real good about letting you use the calculator if things are complex. You'll find in this case, I don't need the calculator because what I'm going to do right now, sneak peek, is get a negative answer, and therefore I'm going to know the global max and mins. So here comes, wherever I see an x, plugging in a 5 pi over 4. I know the sine of 5 pi over 4 is negative root 2 over 2, so I have a positive times the negative, which yields a negative number. So I have two of these cats that are equal to 0. One is positive, one is negative. I now have a list of candidates, and I know full well that pi over 4 is the global max. I know full well that 5 pi over 4 is the global min. Awesome. And this justification, you go candidates test and show your math just as I did, Foster Wheeler AP exam will accept this as justification. I want to show you this graph, you guys, so you feel better about things. Remember, f of x equals e to the negative x sine x. Here's y equals e to the negative x sine x. Look at this. It's easy to see where the global max exists, and it exists at pi over 4. That's what we found. Awesome. A little more difficult to see this, but this thing bottoms out at 5 pi over 4. That's the global minimum. That's what we found. Awesome. We also found inflection points. Remember, these are locations where I changed concavity from, in this case, do you see if you went from left to right, you're concave down, concave down, concave down, right to that point where you then begin to go concave up. So we have an inflection point at pi over 2. We have a second inflection point here. That's the magic point where, and it's hard to see, but maybe I can kind of convince myself, I'm concave up all the way to that location at 3 pi over 2. Click. And then I become concave down. So there's kind of the picture for you that represents all the work you did to find the global max and min, etc. here. Okay? Now you got to practice these type of problems. Check them out. This is Mr. Foster, over and out.